Okay, number one. What we're going to do here is we're going to graph both of these lines, and then we're going to look to see where they cross. Y equals 1/3 x plus 6. That crosses the y-intercept, y-axis at 0, 6. And then it has a slope of 1/3. So that means I would go up 1 and over 3. So that would be up 1 would put it at 7, over 3 would be 3, 7. And then I draw the line. And then y equals negative 1/2 x plus 1. That has a y-intercept of 0, 1. And it has a slope of negative 1/2. That means I start at 0, 1. I go down 1 over 2. So that would be 2, 0. And then I draw that line. And I look to see where they cross. Now, of course, on my graph here, my graph is so inaccurate that we really can't tell. When you go to do this problem on your test, I'll give you a grid and you'll be able to draw a pretty accurate graph. It turns out that the point where these lines cross is the point negative 6, 4. So that would be your answer for that one. Number two, kind of similar. We want to graph these two lines and see where they cross. Again, the first line I would just graph directly. It's got a y-intercept of 0, 3. Slope is negative 5, so I'm going to go down 5 and over 1. So down 5, that puts me at a y value of negative 2. Over 1 means my x value is 1. Connect the dots. I missed a little bit there. That's okay. Now, to draw this second line, what I would probably want to do is get y all by itself. So to get the y all by itself, 3y equals minus 15x plus 9. And then I'm going to divide by 3. And when I divide by 3, I see that I get exactly the same equation again. So what that means is I have exactly the same line right on top of the other one. It means we have an infinite number of solutions. The fancy math word for that is dependent. So we would say that this system is dependent. That would be your answer for number 2. Number 3, we want to solve by substitution. To solve by substitution, you want to take one of the equations and get either x all by itself or y all by itself. Well, this one's really nice as far as substitution goes, because both of the equations already have y all by itself. So all I really need to do is take this equation and plug it into that equation. That means I'm going to have minus 4x minus 3 equals 5x plus 15. And I'm going to solve that equation. I'm going to subtract the 5x on both sides. Minus 9x minus 3 equals 15. Add 3. Minus 9x is 18. Divide. X is negative 2. The last thing I have to do is take that x number and plug it into one of the two equations. It really doesn't matter which one. For no particular reason, I'm going to pick the bottom one. Y equals 5 times negative 2. 5 times negative 2 plus 15. That's 5. So there's my answer. X equals negative 2. Y equals 5. The next question you asked me, this one we want to solve, and we're solving by the elimination process. To do the elimination process, that means I need to decide which letter I want to get rid of, either X or Y. In this case, both of them are a little bit challenging because their numbers are a little bit bigger, but I think I would pick the Y's because the Y's are slightly smaller. So I've got to look for 15, look at 15 and 9 and find their least common multiple. I think the least common multiple for 15 and 9 would be a 45. So I'm going to take this top equation and I'm going to multiply everything by 3. That gives me 75x minus 45y equals 65 times 3 is 195. Then I'm going to take the second equation and I'm going to multiply by negative 5. And the reason I picked negative 5 is I'm looking at my first equation. I've got a negative 45 there. For my y's here, I want to have a positive 45. So I notice that negative 9 times negative 5 would give me a positive 45. All right, so negative 5 times 15, that's negative 75x. And then negative 5 times negative 9 is a positive 45y equals 10. I add the two equations and an interesting thing happens. Not only did the y's cancel out like I wanted to have happen, but the x's also cancel out. So on the left-hand side, I get 0. On the right-hand side, I get 215. When does 0 equal 215? The answer is never. So what that tells you, going back to these two original equations, if you graph these are lines. Since 0 never equals 215, the two lines are parallel, which means they never cross. The fancy math word for that is inconsistent. So that would be your answer for this one. You would click the one that says inconsistent. Okay? All right, moving forward. This one. What you want to do on this one is just go ahead and do FOIL. You're going to have 9y squared plus 9 times 3 is 27y plus 9 times 3y is 27y plus 81. Add your like terms. You have 9y squared plus 54y plus 81. In this one, I remember I saw your answer. You were missing this plus 54. So I'm not sure what happened there. I'm not sure if you forgot to do FOIL or if maybe somehow you made a mistake and you had a positive 27y for one of them and a minus 27y for the other. But they should both be positives. They add up, you get a 54 in the middle. Finally, the last one. You want to solve this equation. Well, what you need to recognize is on the left-hand side, you go ahead and you do FOIL. X squared plus 6x minus 4x minus 24 equals 11. After you do FOIL, you recognize that you have an x squared here. When you have an x squared, that's called a quadratic equation. And what you need to do is get everything on one side and have a 0 on the other. So I'm going to subtract 11 on both sides and combine my like terms. That gives me x squared plus 2x minus 35 equals 0. The reason we want a 0 on one side is it's going to allow us to factor and use what's known as the zero multiplication property. So we factor x plus 7, x minus 5 equals 0. We're multiplying two things together and getting an answer of 0. The only way that can happen is either the first one is 0 or the second one is 0. We solve each of these equations. We get x equals negative 7 there and x equals 5. There's our two answers. Okay, I hope all those help. Let me know if you have more questions.